My name is Shreya. I am studying in Sri Venkateshwara College of Engineering. Today we discuss about the subject mathematics. In that topic, subspace linear space. Introduction to subspace linear space. A subspace of a vector space V is a subset of V that is itself of vector space. Subspace must satisfy closure under addition and scalar multiplication. Subspaces contain the zero vector and are non-empty. Properties of subspace linear space. The intersection of any collection of subspace of a vector space V is also a subspace of V. The union of two subspace of a vector space V is not necessarily a subspace. The dimension of a subspace is always less than or equal to the dimension of the vector space. Basis and dimension in subspace linear space. A basis for subspace is linearly independent set that spans the subspace. The dimension of a subspace is the number of vectors in basis for the subspace. Any two bases for a subspace have the same number of vectors called the dimension of the subspace. Operation in subspace linear space. Addition of subspaces involves taking the union of the two subspace. Scalar multiplication of a subspace involves multiplying each vector in a subspace by a scalar. The sum of two subspaces is the set of all possible sums of vectors from the two subspaces. Subspaces linear space example. The x-axis in R to the power 2 is the subspace of R to the power 2. The solution set to a homogeneous system of a linear equation is the subspace of R to the power n. The column space and null space of a matrix are example of subspace. Linear independent in subspace linear space. A set of vector subspace is linearly independent if no vector in the combination of the others. Subspace linear space example. A basis for a subspace is a linearly independent set of span the subspace. The zero vector is always in the span of any set of vectors. Spanning sets in subspace linear space. Spanning sets in subspace linear space. The span of a set vectors in a subspace is the set of all possible linear combination of those vectors. A set of vectors span a subspace if every vector in the subspace can be written as a linear combination of the set. A basis of a subspace is a spanning the set that is also linearly independent. Linear transformation in subspace linear space. A linear transformation between two vector space preserves a vector addition and a scalar multiplication. The image of a subspace under a linear transformation is a subspace in a codomain. The kernel of a linear transformation in a subspace in the domain. Orthogonality in subspace linear space. Two subspaces are orthogonal if every vector in one subspace is orthogonal to every vector in the other subspace. The orthogonal complement of a subspace is the set of all vectors in the vector space that are orthogonal to every vector in the subspace. The sum of subspace and its orthogonal complement is the entire vector space. Linear independence and basis in subspace linear space. A set of vectors in a subspace is linearly independent if no vector in the set can be written as a linear combination of others. A basis for a subspace is linearly independent set that spans the subspace. The zero vectors is always in the span of any set of vectors. Dimension and rank in subspace linear space. The dimension of a subspace is the number of vectors in a basis for the subspace. The rank of matrix is the dimension of the column space of the matrix. The nullity of a matrix is the dimension of the null space of the matrix. Operations in subspace linear space. Addition of a subspace involves taking the union of the two subspaces. Scalar multiplication of a subspace involves multiplying each vector in the subspace by scalar. The sum of two subspaces is the set of all possible sums of a vector from the two subspaces. Subspace linear space example. The x-axis in R to the power 2 is a subspace of R to the power 2. The solution set to a homogeneous system of a linear equation is subspace of R to the power n. Orthogonality, linear independence and basis in the subspace linear space. A set of vectors in subspace is linearly independent if no vector in the set can be written as a linear combination of the others. A basis for a subspace is a linearly independent set that the subspace, the zero vector is always in the span of any set of vectors. Dimension and rank in subspace linear space. The dimension of subspace, the number of vectors in a basis for a subspace. The rank of matrix is the dimension of the column space of the matrix. The nullity of a matrix is the dimension of the null space of the matrix. Conclusion. Subspace linear space plays a crucial role in linear algebra and various mathematical applications. Understanding the subspace helps in solving system of linear equation, studying linear transformation and more. The properties of operations and subspace provide a foundational framework for advanced mathematical concepts. Thank you.